Hi, my name is Noah Arnold, and this is my Lab 4 for Physics 2212 at Georgia Tech, Circuits. The goals of this lab are to understand the concepts such as loop rule and node rule, and then use them to analyze circuit components. We also want to study the function of capacitors in circuits in states of charge and in states of discharge. We also want to demonstrate the conservation of energy within circuits. A preview of my results would show that current and voltage values given by the model match the predicted values, and in an RC circuit, the magnitude of current is time dependent. In this lab, we need to understand the fundamental physical principles of loop rule, meaning that the change in charge and the potential difference added up will all equal 0 for a round trip. We also need to understand the node rule, which means that the current in equals the current out. Ohm's law is also needed, which means that the potential difference is equal to IR. I chose to do the online lab, and with this, I followed the procedure for the series circuit. The predicted was that the current would be 0.02 amp meters, and the predictions were found to be correct. If you reverse the connection, it just showed the negative version of the answer. And then after connecting the voltmeter, it read 3 volts because it was connected to the batteries. And then when that happened, the ammeter read 0 because the circuit was left open. To look at the measured potential differences in the series circuit, I just went around to each connection, A, B, B, C, C, D, D, E, E, F, F, G, G, H, and H, A, and added everything up. It all added up to equal 0, and we could solve using this to find that the current I equaled 0.02 amp meters. Here is a graph of some observations of the potential versus the position around the circuit. I also have some observations about the series circuit. When attaching the voltmeter, the ammeter does not change because there is a parallel circuit. The current goes between the two paths, and since there is a 0 resistance at the ammeter, it means that all of the ohms go that way and there's a higher current. Here are some resistance calculations. Moving on to RC circuits, if a battery is connected to a bulb, as the time progresses, the light bulb get bright and then gets dim until it goes off. If a bulb is connected to a capacitor, as time progresses, the light bulb gets very bright, dims, and then turns off. And then what happens to the current in this circuit? The current starts very large and then flows till it decreases to 0. Here you can see some different time for the capacitors to charge and for the time for the capacitors to discharge with a 10 ohm and 20 ohm bulb. And here that is linearized in a graph for the time for the discharging capacitor. In this lab, there could have been a few causes of error. There could have been any type of human error. I only ran one trial, and it was not a real model. It was an online model that did not count for real-world scenarios. If I was doing this lab in real life, the ammeter in real life would have a small amount of resistance, so the circuit reading could be slightly lower. But if we were doing in this real life and we used a real battery to charge a real capacitor with no resistor in the circuit, the simulation showed that the capacitor charged immediately. In real life, this is not the case. There are resistance values that would slow down that charging process that we saw online.